we're going to look at the steps to finding the area of a triangle. So the basic steps are to first choose your base. If you have a vertical or horizontal line segment as one of your sides of the triangle, that's what you should choose. But if you don't, then I want you to choose the side that is across from the origin. Now remember, we talked about how you should translate your triangles first so that your leftmost point is at the origin, and that's because it makes everything else just a little easier to do. So if you haven't already done so, you need to translate your triangle, and then you also need to find the distance of your base. Okay, so step 2 would be to write an equation that goes through the line segments that contains the base. And I've got typos throughout here, I apologize. So the next step would be to write an equation of a line that is perpendicular to the base through the one point not on the base. If you choose the side across from the origin, the one point not on the base would be the actual origin, which is the 0, 0 point, which makes things really simple to do. Okay, the next step would be to find the intersection from the lines you found in steps 2 and 3. You need to remember that your intersection is a point, so you've got both an x and a y value there, and you should give me that point as an ordered pair. The next step would be to find the distance between the intersection, the one you just found, the intersection point, to the one point not on the base, and that's going to be the height. And then you can determine your area using the formula area equals 1/2 base times height. Now the problem that we're going to look at is this problem down here. I've called this problem 5, so you can call this problem 5 as well. But this is the problem that we're working on. Okay, so if we look at these, I'm going to label these particular points as, we can zoom in here so that we can get a better view of what we're working on. So you've seen this in class, and I'm going to just work on this bottom problem. So if I label these as X, Y, and Z, my first step would be to move this ordered pair here. I want to move X to the origin, and I want to do that because I want to deal with as many positive numbers as possible. And I realize this isn't a difficult triangle to work because we've got one vertex on the x-axis and one on the y-axis, and so it's a pretty easy one to do anyway, but it's just good practice. So if we move X to the origin, we are going to first determine what our X and Y value and Z values are. So you can sit there and look at your worksheet, or we can just see what I've done. So if X is at -6, 0, I didn't fix this as I went through, so let's fix this real quick. And I want X to be at my origin. I would be adding 6 to -6 to make it so. Okay, so my rule that I would use is I'm going to use the rule of X plus 6, and then I'm not doing anything to 0 to stay at 0. Like I want to get to that ordered pair of 0, 0. So I'm going to say -6 plus 6 gives me 0, and 0 is already at 0, so I'm not doing anything to my y values. So if I look at y here, if I look at y, and I'm already at 0, and I'm adding 6 to that, I'm going to be at 6, 4, because again my y value is not changing. And then for z, if I'm going to say 2 plus 6, that would be 8, -3. Okay, so my y values didn't change, just my x values, because I look at one particular point and say, what do I need to do to move x to the origin? Okay, so you pick which point you're going to move to the origin, and that's what you need to follow the same rule for every other ordered pair. Okay, so down here, if I'm moving X to the origin, my origin is right here. So this point right here would be X prime. Okay, and then Y, I'm moving 6 units over, so I've got 1, 2, 3, 4, 5, 6. So that's going to be y prime. And then z, because I'm not moving my y values, I'm just simply adding 6 to my z value. So I'm at z prime. So my new triangle would go from here to there, and from there to z prime, and from z prime to x prime. So it should be the exact same perimeter and also the exact same area. But when we translate it, when we move it from one location to the next, we're able to make our problem a little easier to solve. Okay, so that was the first step that I asked you to do. Now if we look at this, we've got to choose our base. And I don't have a vertical or a horizontal line, and so I want to choose the side that's across from my origin. So my origin is right here at x prime, and so the line or the segment that's across from my origin is going to be right here, y prime, z prime. So this distance here is going to be my base. Okay, so if that's my base, I can start working this problem. Okay, so first we're going to choose the base. And if you haven't already done so, you need to find the distance of that segment. Okay, so I can quickly do that. I'm going to use these ordered pairs right here. Okay, so I have the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And if I substitute my given information in, I've got 4 minus a negative 3 squared plus 6 minus 8 squared. So now 4 minus a negative 3 is a positive 7 squared, and 6 minus 8 is a negative 2 squared. So 7 squared is 49, and negative 2 squared is positive 4. So my distance between these 2 points is the square root of 53. So the square root of 53 units would be my base. And if you haven't already done so, that is necessary in order to find the area. We need the base. Okay, so that's going to be step 1. So now I want you to write an equation of a line that contains those 2 points, that contains the base. And so we know the equation of a line is y minus y1 equals m times x minus x1. Okay, so if I'm using these 2 points, I first need to find my slope. Okay, so my slope, remember, is m, which is y2 minus y1 divided by x2 minus x1. And if I substitute my numbers in, I have 4 minus a negative 3 divided by 6 minus 8. And that gives me a negative 7 halves. So my slope is a negative 7 halves. So that's what I know. M is equal to negative 7 halves. So I'm going to use that slope, negative 7 halves, in one of my ordered pairs here to find my equation of a line. So I'm going to choose to use this ordered pair because I like to deal with positive numbers. So I'm going to say it's x minus 6 because the 6 is my x1 value, and y1 would be the 4, so I'm going to say y minus 4 equals negative 7 halves times x minus 6. Okay, we don't like working with fractions. You guys have told me you don't like working with fractions, so we don't need to, but we can clear the fraction. And so right now, do you see this denominator of 2? Well, if you want to not work with fractions, you simply multiply both sides of your equation by a common denominator. So since we only have one fraction, we don't have to have a common denominator, we have one denominator. So the denominator would be a 2. So I'm going to multiply both sides of my equation by 2. And when I do that, I simply have 2y minus 8 because I'm going to distribute, is equal to, and on this right side, my 2's cancel. And because they cancel, I am left with negative 7 times x minus 6. Okay, now I can distribute on the right side of my equation, which would be negative 7x plus 42. So I have 2y minus 8 equals negative 7x plus 42. I would add 8 to each side. So I get 2y equals negative 7x plus 50. And then divide both sides by 2. And when we do that, we're left with the equation of y equals negative 7 halves x plus 25. Okay, so the equation of a line that contains the base is negative 7 halves x plus 25. The next step says write an equation of a line perpendicular to the base through the one point not on the base. Okay, so the equation of my line of the base was y equals negative 7 halves x plus 25. And I want a line that's perpendicular to this. So you need to recall that if you have perpendicular lines, that your slopes are opposite reciprocals. Okay, so an opposite reciprocal is, again, when your numerator and denominator switch positions, and opposite means different signs. So I currently have a slope of negative 7 halves, and so the opposite reciprocal would be a slope of positive 2/7. So my slope is equal to 2/7. Now, this equation needs to follow y minus y1 equals m times x minus x1. My slopes are opposite reciprocals, and I'm going through the point not on the base. Well, guys, this is going to change depending on what you chose as your base. But if you followed what I asked you to do, the one point not on my base is my origin. It's my x prime, which is what we decided is our origin. Okay, and I chose that because it makes everything really easy. So the one point not on the base is 0, 0. Okay, so I'm using my slope of 2/7 and my ordered pair of 0, 0 as my x1 and y1. And when I substitute that information in, I have y minus 0 is equal to 2/7 times x minus 0. Well, if I distribute, I simply am left with y is equal to 2/7 x. So the equation of a line that's perpendicular to the base through the one point not on the base is y equals 2/7 x. Okay, so what I currently have is a triangle right here. Okay, looks similar to this. I've found the equation of this line right here, the line of my base. I've found the equation of a line that's perpendicular to my base that goes through this point, which we have decided is our 0, 0. So a line that goes through this, and it's perpendicular. And so I know my lines, I know this point here, but what I have to find now is this intersection. So that's our next step, okay? We know this point here is 0, 0, but we're looking for the intersection. And what's important to remember is that when two lines intersect each other, they intersect at a point. So you have both an x value and a y value. And that x value and y value is exactly the same for both lines. So that is the information we're using for the next step. We're finding the intersection of the lines from step 2 and step 3. Okay, well, from step 2, your equation was y is equal to negative 7 halves x plus 25. And from step 3, you had the equation y is equal to 2/7 x. Well, if y is equal to y, then negative 7 halves x plus 25 must equal 2/7 x. So if I have 2/7 x on one side, and I have negative 7 halves x plus 25 on the other side, I'm simply solving this equation. Okay, so I have fractions on both sides now, and I don't like working with fractions. So one thing that I can do is multiply through by a common denominator. And here, I've got two denominators, one is 2 and one is 7, so a common denominator would be the number 14. So I'm going to multiply both sides by 14. So I have 14 on my left side, and I have 14 on my right side, and I'm going to show that I am multiplying everything through by the same number. So I'm going to change some colors here so you can see exactly what I've done. Okay, so I'm multiplying every single term by the exact same number, and that doesn't change my solution, that doesn't change anything. It makes the problem easier for me to work because it's given me an equivalent equation. Okay, so now I'm going to simplify, and I can say 2 goes into 14 7 times, and 7 times negative 7 is negative 49x, plus 14 times 25 is 350. And then I have 7 goes into 14 2 times, and 2 times 2 is 4x. So I have this equation here, which is a little easier to work with than a bunch of fractions. So now I want to isolate my variable term to one side, so I'm going to move that negative 49x to my right side. On my left side they cancel, and I'm left with 350 is equal to 53x. And then I will divide both sides by 53. So I'm left with 350 divided by 53, and that gives me that x is pretty close to about 6.6. Okay, but remember I'm looking for both an x value and a y value, and currently I have this x value is 6.6, but I'm still looking for this y value here. So what I can do is substitute it into either one of my equations. Well, I don't really want to use this one here because it's longer than this one here. I just want to pick the simplest equation to use, and currently the simplest equation would be y equals 2/7 x. Okay, so if I change colors here so we can see, So we're solving for y now. Now that we have x, we need to solve for our y value. So we have y is equal to 2/7 x. So we can say y is equal to 2/7 times 6.6. And when we do that, we get that y is approximately 1.9. Okay, so our ordered pair is 6.6 and 1.9. And that's our intersection, because an intersection is a point, and a point has both an x value and a y value. The next step would be to find the distance of the line of the segment between the point of intersection and the point not on the base. Okay, well, the point of intersection is 6 6/10, 1 9/10. And then the point not on the base was our 0 0. Okay, it might change if you choose to use a point that's not 0 0 as your base, or as your 1 point, but not on the base, but that's totally up to you, and I highly suggest that you use my method. Okay, but if you choose another way, that's fine. Your area should still be the exact same. You're just going to cause yourself a little more work. So now we're going to use that distance formula that says distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And these are my two ordered pairs here. And so if I have 6 6/10 minus 0 squared, I'm left with simply 6 6/10. And if I have 1 9/10 minus 0 squared, I'm left with 1 9/10. And remember, I'm taking the square root of these numbers. So the square root of 6 6/10 squared plus 1 9/10 squared is approximately 6.9 units. Okay, and this is just from what we did in the class, and I used students' work, so I'm hoping that our decimals here all work out. But 6 and 9 units. Guys, this is your height. So in our equation of area is equal to 1/2 base times height, this is the height. Okay, so my last and final step is to use that formula. Area is 1/2 base times height. So area is 1/2 base times height. We've already determined that the base is the square root of 53 units. The height is approximately 6.9 units. Did I put 6.9? Yep, good. Okay, and so when you multiply 1/2 times the square root of 53 times 6.9, you get that the area is pretty close to 25 units squared. Okay, so that would be your final answer. It's going to take some practice, it's going to take some work, but this gets you to that level 4 status that so many of you want to be at. Thank you.